So hello everyone, my name is James, as you can see. So today I'm talking about enums and 10 metric, I should mention. I'm a PhD student up at the University of Auckland, so that's who I am. I'm not actually working in Rust right now, but I do like it and pay some attention to it. I have, I'd say I'm probably at the sort of advanced beginner to intermediate stage. And I was mentioned that everything in today's slides pretty much is based on chapter 6 of the book, which is the just programming in Rust or something like that. I forget what that name. Although that was like a year ago version, so it might have changed slightly since then. I won't do that. Right. So, what's that? Enums. So hopefully people in some idea what I'm saying enum. And so you're probably actually thinking, well, hang on, like enums are ancient, 10 C and such for a long time. And C enums aren't anything new. In fact, I think Java enums for a long time are basically the same thing as well. But Rust's enums are a bit different to that old stuff, because the old ones are basically, it's just, you're essentially swapping a name for a number, or swapping a number for a name, one or the other. And when you sort of got down to it, they're actually just numbers in the background. The Rust enums are actually proper types, and then contain things, and we'll get to that later on. And so generally the main idea of them is that you use them to group together related types to some form or other. And we'll see some examples. Right, so just so you know, enums are known as lots of different names, really. Oh, what Rust calls enums, I should say, known by lots of different names. So basically they're the same thing. Meetup, which is one I obviously called discriminated unions. Haskell, they're often called algebraic data types. You also see them called sum types a lot when people talk about mathematical stuff. And also I've seen them called OR types, although as we'll see later on I have just a session called exclusive OR types. In the slide title. So the point of enums is you're using them to represent some different but related types, where whatever you've got can be exactly one of those types at any given time. So they have an exclusive or relationship. And so the example I'm going is the Rust book gives an example of IP addresses. So you can have an IP address, it can be IPv4 or IPv6 or probably something else, but no one ever uses anything else. But it doesn't make sense to have one that's both of them at once, because that just doesn't make sense. You can have one with the other, but they're not the same. There's no overlap between them. Well, there's a conceptual overlap, but an implementation overlap is not there. Right. So a very basic example is if you just want to have the colors of the rainbow. So you think, okay, so I should call it rainbow actually, like rainbow colors. Anyway. If you're saying you're working with something and it's a particular color, it can only be one of these colors at a time. So you're just going to give it one of those colors. If for some reason you'd want to have something. Well, basically you've got a situation where something can be exactly one color at any given time. Otherwise you could do something like maybe a struct where you're label together or something. We'll come back to that. Right. So this is basically our declaration about enum. So you've got enum, the name, and then you've got the different cases that it can be. And so these ones are just basic. So this looks pretty much the same as a C, enum or Java enum right now. And it kind of is. And so then, just to use it, you just say, okay, let variable name equal, and then your enum type name, and double colon, and the enum case. That's in it. That's just as simple as that. Of course, these are the ones where you've just got the names, basically, so that's pretty simple. So it's just, see there. So that's the very basic method. And so, yes, that's okay, that's great, but what do you do? No one really cares, it doesn't seem exciting. But there are two things about enums here which are very handy. One, pattern action, which we'll talk about in the second afterwards. And two, you can actually have types inside your enums, which you can have see it. It used to be able to Java. So like here, for instance, we've got some different animals, and for some reason each one of them's got a number associated with it. And so again, you'd be saying, okay, for some situation I can have, well, I mean, if you've got an animal, generally it's only going to be one of those. It's pretty rare to have something that's both a cow and a horse and an alpaca. Okay, similarly. So the point is, you can actually have, some other type inside it. So you can have a goat, and then you can give it that number, because if you remember, these ones are all just numbers on the inside. So I mean, you can have a different type. You can have basically any legal type, generally speaking. You might run into some funny things about sync and send and that sort of stuff at some point, but generally speaking, there's no real restrictions on what types you can have contained inside your categories of an enum. And in fact, of course, you can actually change which category of an enum you're using as a variable. So when you've got a mutable variable, it can change its case quite happily, because the C and G won't have the type or McDonald in this case. And so it means the compiler knows, okay, it can be any one of the cases in that enum. I'm just going to look at it as the enum, and then you deal with it later on. There's a lot of good pattern matching that comes in. And so that's really when you get that thing of you bundle them all up together. It's in the compiler can look and be like, okay, I know it's going to be one of these things, so I'll just handle that carefully. But I know it's always going to be one of these cases, and then that means you can happily. It's not generics, but it actually does mean you kind of have a very limited formula in a way, because you can have any one of those things involved. Right. So the point is, so you have basically enums for when you've got different types of things that are logically connected, so you want to be able to treat them all to get in the same way at some points. And there can only be exactly one of these types at a time. And there could be differences based on which one you've got. There's still some connection between them. And obviously you want to be able to move between cases as need be. And you can give them different types. So not only do you have different names, obviously, and you can have stuff contained in them, you don't actually have to have the same stuff contained in them. Like we've got here. So again, this is straight out of the book. Basically, they're saying, okay, these IP addresses, we could represent them completely differently if we wanted to for some weird reason. I'm pretty sure there's not a good way to represent an IP address, but that's plenty of point for this one. So you could have one IP address, a v4, which is just a bunch of e-weights, because that's always up to 255 for any given field, not mistaken. So you could just say, okay, every IP address is going to be 4 of those 255, 0 to 255 types. Again, I would probably recommend doing it in that way. Or you could have IPv6 represented as a string, because it's complicated and crazy. So the point being that you can have completely different, inside your enum, cases contain completely different types inside them, if that makes sense for your situation. And of course, as you probably know, you can happily have structs or enums inside your enum cases. So basically any legal Rust type, generally speaking, is going to go into them. And so the other important point, which is actually very handy, is that so for enum, you can also implement methods within, just like you do with structs. So I don't know if people are really familiar with implements for structs. Basically what happens is you say, okay, I've got, so I forget the term they use for it, but it's basically the same thing as an interface in something like C# or Java. You declare that, and then you say, okay, so I've got my enum, I'm going to implement an interface, implement it for my enum, in that method. And so you get implement method. And I just realized I've actually completely forgotten to include a bit showing you how you handle each different case, which is the other side. And off the top of my head, I actually can't remember. It's been a while since I've had a chance to play on enums and this was fresh. But basically you'd have a thing, for each different type, do whatever you need to do. Or in fact, for all of them the same, you can just say you have one thing. And again, we'll sort of look at some of that in a second. And so the point being that you can implement your interface on it, and then you can use that. Okay, that's probably not true. But the point being that now there's a foo method associated with IP address, so anytime you need a foo method, for whatever reason, that I think I've written that correctly. Anyway, it's just looking at books. I'm pretty sure I've got that wrong there. Right? I don't think you can.
No, you can.
Yeah, no,
you can implement enum.
Yeah. No, I was just thinking. Oh, you didn't implement enum. I'm just thinking you might have written it slightly incorrectly because I'm not really saying what I'm implementing there on the. Anyway, no, I think that is correct. Sorry. But it's been too long since we actually had a chance to read the last properly. And so then basically you can go and use that method as you need. And of course the nice thing being that you actually, as long as everything is in the same scope eventually, you can actually define them completely different places if you want. Right, okay, so that was enums. Hopefully that all makes sense to everyone. There's not a huge amount to them, but they're very, very handy. Right, and so we get to pattern matching. Pattern matching is really where there's a point in enums. Up until then, they're good, but not great. And so probably the biggest place that you're going to see being broken down is in match constructs, which if you don't know match constructs in Rust, similar to old switch statements from C++ and Java and I think C++. But it goes beyond the switch statement really. And I've seen them called switch on steroids before. And so pattern matching it's found in pretty much all the ML derived languages, which Rust is typically one of. Don't worry if you don't know what that means, it's not here. But so I've got examples of that, so things like AKL and Sharp and Haskell and Swift actually. And Erlang, which again is a functional language, it does pattern matching a little differently. Basically owing to its origins originally implemented in Prolog, but it pretty much entirely runs with pattern matching. That's basically something to bear in mind is that when you're doing pattern matching, the first essentially define the cases and just goes down sequentially. And the first one that whatever you're working with matches is always going to be one selected, so it's just as a top-down search basically. So just bear that in mind. Right, so here's a very basic example where we had our rainbow thing from earlier, our rainbow enum. So just saying, okay, match on some variable called a color, and then for each possible case, print something. And so a very nice thing about enums and Rust and some other languages is that here, if for some reason I got rid of say violet at the bottom, the compiler would start saying, hang on, you haven't actually covered all the cases, you've completely left one unhandled. What if that A color actually happens to have the type rainbow violet? What's going to happen there? And so it will, complain and say, no, you've got to actually put something in there because, the undefined A or something otherwise, which safe Rust generally tries to avoid. So one of the great things about pattern matching combined with enums in particular is that unless you've got like a bazillion cases, it's pretty easy to make sure you've got them all in there handled. So here's much the same thing, but slightly different. So just see if you can spot the difference in a moment. Right. So the thing about that is, I'll go back to this now. So that's the first one. So basically we just say match on our variable and then print something given depending on what it is and carry on. The second one, however, is actually assigning to a variable. And so what we're saying is for each given case, we're going to return a string. And so if you're not running Rust, basically the last expression that you have in your function or whatever is always going to be the return value. And so basically what happens here is this whole thing ends up returning a string. One thing I will point out is that you do need to make sure that the types that come out of your match statement, as with functions and whatever, it always has to be of the same type. But that's again where enums can come in handy, because if you've got two different types that you want to return, but clearly there'll be some logical connection between them because if they fit into the same match statement, there must be some connection. In that case, you can basically slap those both into an enum, and that combined type is going to be your return type, essentially. So the point is with this one, returning a string and actually assigning it to a variable whereas in the previous one, we're just printing it. So here, I didn't want to put it in to make it too obvious, but here we could have an next lines printing colour word as whatever we got out of that. And so obviously whichever one makes more sense is going to depend on the circumstances. But the point of all this is that the match construct as a whole, basically at the end of it, all evaluate to some value. Everything in Rust is expression, so everything in Rust evaluates to some value. And so you can, if you want to, assign that value to something. If you're just doing it to, get some side effect like printing or I or something, you don't need to. But you can actually just have the whole thing say, okay, for each given case, I want different, whatever it is comes out of the match statement, be assigned to a variable. And so you can do that, which is probably the biggest difference I can think of between match statements here and switch statements in C, is that C just didn't work like that. And so that can be very, very handy, being able to just assign the result of a whole match construct. So basically, you go in, so we'll come into here and we'll look through all of them, and so, okay, match a colour, and so then, in this case, it's not really very hard. We'll just say which one of these happens to be the right type, right case, a colour, and then I'll go and do that thing, and then once I've done that one, I jump out. So another thing to note is, unlike C++ by default, cases would just fall through once you'd hit the first one, or just keep dropping down into the other ones. That doesn't happen here. Basically, it finds the first one that matches, executes whatever's on the other side of it, on the right-hand side of that one, and then that's the whole result of the entire match statement. So in this case, basically, it just creates a string and returns it. Right. And so then, whatever comes out of that, mucking about on the right-hand side, becomes the result that comes out of the match statement, and if you're assigning it to a variable, what goes into the variable. And so one thing to note, which can be a little confusing, is if you go look back here, you can see, because in each of these things we've only got one single statement to make up each result, which is basically just declaring a string. We can just have a comma between each case. But if we wanted to do two or more things for a given case, then we actually need to put curly braces around it and have semicolons in each of the lines. So basically the same as functions really. I mean, in fact, you could have, if the coin is that, then just run some function, say, or whatever. And if I'm not mistaken, you could even have the function use the variable coin if you wanted for some reason, knowing now that it's going to be penny. Although, you don't do that, but I'm pretty sure you can. Right, so the point being that whatever's going to come out of this batch statement, the final result of it is going to be 1. But in the process of getting there, if penny is selected, it'll also print lucky penny to the screen. Right. So the other interesting thing to note is what's called deconstruction parameter. I think it's another name for it as well. Basically, the point being that you can actually have some parts of it specified as literals, and some parts are specified as variable names, and some parts are just ignored. So the underscore basically means, ignored, don't care. This will match with anything. Just for an example. Another thing to note is, say, so here, got the different cases. And as I said before, if I missed out a case, we complain. But I could have at the very end an underscore instead, and that would be the catch-all, all other situations do blah thing. So, maybe if you're thinking it should never be in that same, should never be in a situation where it's not one of the ones you explicitly specified. You could have something like, throwing a panic or returning an error in the result or something like that. And the other thing to do, of course, is, as I said, it goes top down to find the cases. So if you have an underscore as anything but the very bottom case, you'll never get the things below it because it'll always match on that and stop there. Right. But so this one here is quite, somewhat interesting. So the idea here is that you're looking at IP addresses, and so we're saying, okay, there are different formats of the IP address you can be interested in. So we're trying to pick out home addresses for IPv4, we all know that those will start with 192.168 or 127. And so you can have basically the first two bits are going to be, or the first bit is going to be a number, specific given number, because you're specifically interested in that number in particular. And so it'll match for any IPv4 where it has those numbers in the front. But if it doesn't have those exact numbers, it'll carry on to the next case. And so we've got the little bar there which is basically saying, okay, these two we can treat the same, they have the same final result. So instead of defining them separately, we can just have, it's that one or that one, carry on. And so we've got here 192.168, and then, so just to demonstrate, we've got something saying who cares. So basically, it's going to assign the value stored in that position in the enum into a variable called who cares, which we could use on the right-hand side. And then we've also got a semicolon, but we just really don't care at that point. We're just trying to detect if it's the home address, not the exact details of it. Whereas here, say, for countersign, but you can see basically we've got, okay, in this case, it doesn't match exactly to one of those literal cases that are specified, so we're just going to match the whole thing and bundle up into a bunch of variable names. And so then in my right-hand side, I could use any one of those variable names, all of them as I please, to do whatever I need to do. So they're just regular variables in the book, basically. Let's see if I can go across slightly. So you can see here, I print out a line using whatever's in that first segment of it. And in fact, in this case, we could easily quite happily change second, third, fourth to underscores because we're not actually using them for anything. There's nothing wrong with naming them if you want, but you don't need to. But arguably, it's not clear. Other people reading it, they're not important. But there are some part of stuff to be smart enough just to get rid of creating variables for them if you want to use them. And of course, finally, get down to IPv6 and just do whatever. And so again, of course, in this case, because we only had v4 and v6, it's not going to say, oh, you missed a case. But if for some reason we didn't have v6, we would complain. Or we could just have a semicolon, the underscore, and say something generic. Like not an IPv4 or something, say. But of course, we couldn't actually use anything specific to IPv6 in that case because we haven't seen it's going to be an IPv6 case. It's just anything else that could possibly come through. Right. So that's a very quick introduction to both of those topics. So basically, the point is enums let you essentially group types together when you have some sort of relationship between them where whatever you're dealing with can only be exactly one of them at a given time. It doesn't make sense to have some combination of the two, like we had before with goats and chickens and horses and that. You can probably assume that on a normal farm you're not going to have something that's part goat and part horse. I'm assuming. And so yeah, basically the idea is you can group all these together into one super type, and then in a lot of places you can just use that because you can say, okay, it can be this one or that one, and I'm not going to know until runtime essentially. But I can have them grouped up together to make the Rust compiler happy, and then I just do some pattern matching later on to figure out which one it is, and then I can respond as appropriate. And the enum cases themselves, they don't have to be the same type. They can have completely different types inside them. You can mix ones which are just the name with ones which have types inside them or not. So you could have, all the colors, and then you could say green, for instance. Maybe for some reason you want to have strings associated with just green, so you could have all the rest are just the names, and then there's strings and green for some reason. And so pattern matching, you can do it on absolutely any sort of variable. But enum is probably one of the obvious ones where you're going to use it a lot. So basically you say, okay, I'm going to match on that, and then for each of the different cases I'm going to specify what happens if my enum happens to be in that case at a given time. You can also match on literals, I should say, so inside the cases you can include literals. So if you've got, say, a number and you want to handle the cases of 0, 1, 2, and 3 specifically in some way, and then absolutely every other number in some different way. You can say, okay, for 0, 1, 2, 3, I'll just put those in as literals and say, do this, and then every number, and I'm not just using an underscore, because I'm going to sit there and list out every single possible number. We're going to list out every single possible number by hand and do something with it. And you can also bind those values that you're getting through to new variable names if you want. And basically, to my mind at least, once you got used to those, you're going to be like, oh, wait, why can't I have those in this other language? Because they're actually really handy in this language. You had a question?
Yeah, just on the back on that example you had just back there.
That one?
Yeah, so like, say you, I mean, it probably doesn't matter at all, but like the 192.168, the first one there you've got, can you actually, like that match, can you assign that to a variable like you've got below, you've got first, second, third, fourth. Say you wanted to send that match to a generic function that's doing something, instead of having to code a specific version of the, call to the function saying 192.168 blah blah.
Yeah.
You can actually, can you do a 192 assigned to first and 168 assigned to second, and then just to make it, like I said, it's probably a moot point because you can just put in a call to a function having 192.168 for that. But when you're kind of copying code around, I'm just thinking about reducing the amount of times I have to duplicate.
Yeah, I don't think you can do what we say. Can? Okay.
You go on into at variable name.
And it'll assign it to that.
Is that what it is?
Yeah.
Okay.
I'm just wondering about
I
that.
don't know if you've seen it.
I mean, it's a lazy thing.
Yeah.
and
Oh, no,
what I'm
no,
asking,
it's a
but-
reasonable question.
Yeah.
Okay, but you can do it. I don't think I'll ever use it. So, I mean, for me personally, does that, if it mattered that I need to know 192, I'd just write 192 as literal. But I mean, if you're going to have like a whole bunch of things that are using 192, you might want to say the first thing in your right-hand side is just going to be, okay, front is equal to 192 or something. And then I can just keep using that instead of manually specifying it. I mean, in the case of an IP address, that really shouldn't change, but when you're using some type of substitute make well for different story.
Can I add a point?
Yes.
Yeah, so there is one use where you do want to bind it to a variable.
Yeah.
So 192 at first and the other side 127 at first.
Mhm.
Now you're matching on the first octet for both IPv4,
Yeah, exactly.
and you don't know what that first is in the right hand side,
Yeah.
but it's not common.
So like to do with standard pattern matching,
Yeah.
Perl and all the rest, you can kind of save parts and use it in another part of the match.
I don't really know about that. I imagine you probably got some. Yeah. I mean,
Cool.
generally speaking, if you're going to have like just a little specified like that, you're sort of assuming, okay, the important part is I know it was a home address, and then after that I don't really give a stuff what it actually contained. I mean, maybe that's, for this example, that's what we're getting at. It might not be sensible in other cases, but the point being that, we know we're going to sort of call out those ones specifically and translate them separately. And the thing about, of course, being that we spot the two IP address v4 lines around, we'd never get to the second one because we'd always match on the first one, because they're all just variable names. So anything contained in all the four of those UX is going to get matched on. Yes.
And the underscore just absorbs that.
Yeah,
data,
basically,
and you've got no
yeah.
use, you can't use it
Pretty
after
much,
that.
yeah. So you're just saying, once I know the time address, that's of no relevance to me, so just check it out. I mean, you could quite happily have done it for who cares part here as well, because who cares? I think I just left it in for demonstration purposes. Yes.
Okay, so let's take the first match expression.
Yeah.
Let's say your print list has who cares used, or it's just any expression that uses who cares.
Yeah.
And let's say we change IPv4 to some other variable that part of who cares. Well, is that just not undefined behavior?
Which part? Sorry.
So
here's
the
part.
v4 part, let's change the variable name from who cares to anything else.
Yeah.
Let's say it matches on the IPv4 part, but then it's going to want to use who cares in the print and line.
Yeah.
So is that?
That'd be totally legitimate.
Yeah.
I mean, generally speaking, if you've got so basically what would happen is okay, I've got 192 and 168 in the first two, so it's going to, if you actually use it, if you don't use it, requires for it just going to chuck it out. But if you've got it there and you use it on the right hand side, then it'll stick whatever that fed value is into who cares, and you can happily use it for whatever.
Yeah.
But can you have who cares as one of the variables, say in the IPv6 case?
Oh yes.
And those would be totally different types.
Yeah,
one's
yeah.
in integers, one's in strings.
So
That would just be scoped in that
yeah.
line.
Pretty much.
Yeah, so their scope will
Yeah.
only be in that expression, yeah.
Yeah, so I mean, you could have, obviously you can't have in the same single pattern, you can't have it twice, because they'll say, well, hang on, it's not the same name for two different things. But yes, you could happily use who cares in all of them if you want to.
It's like declaring a variable who cares, but just for that match.
Yeah, pretty much.
Yeah.
Yeah, so I'm saying the right hand side for each one is actually set the scope. So basically, whatever you have given a name in your left hand side for that particular one is going to be available as a variable on the right hand side for that one. Well, I mean, it doesn't make sense to try to use one in a different case if you don't want that case. You can't sort of reach into another one and use it. It doesn't make sense. Yes?
I'm just wondering if I've misunderstood the variable names that you use. So the who cares is not something that's coming in that you're matching with, like a 192168, and who cares has got a value that you're matching through. It's
No.
actually assigning whatever's
yeah,
in
yeah.
that same.
It's putting it to the.
How do you do
If I'm not
that other
mistaken,
way?
you can use a variable from outside. You just have your variable declared outside. So if we said, magic number equals 1, 2, 3 or whatever, and then you could put magic number in there, and it would just match on that.
Ends up the same thing.
I think you need literals. You can't have.
Can you? I can't remember now. to be
It
honest.
just left the AKL part.
Doesn't really matter.
Yeah, like, at the end of the day, you
Make
can't do it
doesn't make sense.
dynamically.
Yeah.
It has to be because at compile time, it will go through and the compiler will actually check every expression is valid.
It's
Yeah.
done. This would throw up errors at compile time if you had things that didn't.
I mean, the
match.
idea between a match is that it does an exhaustive match.
Yeah.
As it, yeah.
It's not. Yeah.
I have to confuse it with different things. Sorry, I'm misleading people. But yeah, so generally speaking, you use the literals and things, but I mean,
You can break things if you didn't.
yeah,
Potentially.
I'm sure there'll be some way to use variables from outside. I just can't think of what's probably some wacky macro magic or something. Right, any other questions? That's basically what I had to say. Okay. Oops, so, point is, this was very much just a quick introduction around the mistake. Actually, start a couple of things. So, chapter 6 of the book, at least a year ago, was all about enums pattern matching, and then chapter 18, obviously not for everyone, was all about different types of pattern matching you can do, and so it gets into some much more complicated stuff. And if you want to see examples, you can basically look pretty much any Rust program since 1.0 to find enums pattern matching somewhere in there, because basically every single one of them, the most trivial programs possible, is going to use them somewhere. Yes. Any other questions? No, okay, I think no. Thank you.